Hello, today we are going to cover lesson 1.5, angle relationships. So by the end of this, you will be able to use special pairs of angles and identify and use perpendicular lines. In this 5-minute check, we know we have angle MON, not to scale. Ray OP bisects MON, that means that these are congruent. MOP, the measure of angle MOP is 40 degrees. We're trying to find the measure of the whole thing. That means we just multiply 40 times 2, or add 40 plus 40, and we get 80. These are our new vocab: adjacent angles, linear pair, vertical angles, complementary angles, supplementary angles, and perpendicular. So this is another vocab-heavy lesson. Our first term is adjacent angles. Two adjacent angles lie in the same plane and have a common vertex and a common side, but no common interior points. So for example, these first two, angle 1 and angle 2, share a vertex, they share a side, but they don't have any common interior points inside of them. Same thing with this next one. Angle 1 and 2 share a vertex, share this side, but they have no common interior points. Angle 3 and angle ABC are non-examples. Although this first example, they do share a vertex and a side, angle 3 is common to the inside of angle ABC. And then this next one, angle 3 and angle ABC do not even share a vertex. Next, a linear pair is a pair of adjacent angles with common sides that are opposite rays. This just means they form a line. So, angle 1 and angle 2 here. They are adjacent, they share a vertex, they share a side, they form a line. Angle ADB and angle ADC are a non-example. Although they are adjacent, they do not form a line, so they are not a linear pair. Vertical angles are two non-adjacent angles formed by two intersecting lines. So we have a line here, we have a line here, they intersect. Angle 1 and angle 2 are vertical, and angle 3 and angle 4. I like to think of a V with a V mirrored under it, with two that's formed by two lines. Is how we can find our vertical angles. And because this is not a line here, we know they cannot be vertical. So in a couple examples. Name an angle pair that satisfies the condition two angles that form a linear pair. So they must create a line. So I'm going to choose a line, and they must be adjacent. That means they're buddy angles. They share a vertex and a side. So I'm going to say that this is the vertex and the side they share, and this is the line they create. So I name my angles angle TIP and angle PIQ are linear pair angles. Next, name an angle pair that satisfies the condition two acute vertical angles. So they must be less than 90 and vertical. So they share a vertex point, but no sides. So I'm going to go ahead and say that here's a line, here's a line. I have this angle here, this angle here. They share our vertex point, but no sides. And they are formed by two angles, and there's two lines intersecting. So angle UIT and angle QIR are two acute vertical angles. Now we need to name two adjacent angles whose sum is less than 90. So we can go ahead and get rid of two of these that are already greater than 90 in themselves. Adjacent means they must share a vertex and a side. So we have two pairs that will work here. We have angle BAC and angle CAD. Those add to be less than 90. as well as angle NAF and angle FAE. So these two as well. We don't want to use angles BAC and angle FAE because those are vertical. They are not adjacent, and we want specifically adjacent angles. More vocab. Our vertical angles, as you'll see in our diagram here, are congruent to each other. That means they have the same degree. So we have two sets of congruent angles. Complementary angles are two angles with measurements that sum to 90. So you'll notice they can be adjacent, that sum to 90, or they can be non-adjacent, just two separate angles that add to 90 degrees. Supplementary is similar to complementary, but they sum to 180. Once again, they can be adjacent to each other, or they can be two separate angles that just add to 180. And a linear pair is a specific kind of supplementary angle. It is when they do form a line, you add them, they equal 180. So the next two problems are very similar. This one, though, where you're talking about supplementary, the next time we'll talk about complementary. So I'm going to draw a not to scale picture of two angles that are supplements. The first one is 6 less than 5 times the measure of the second angle. I'm going to call this first one angle 1 and the second one angle 2. So in the end, I want to find the measure of angle 1 and the measure of angle 2. So I just need to set up an equation. Since we know supplementary equals 180 degrees, I'm just going to take 5x minus 6 equals, plus x equals 180. Go ahead and solve by combining like terms and moving things around. X will equal 31 once we divide. Now we know the measure of angle 2 is simply x. So, measure of angle 2 is 31 degrees. There's a couple ways we can go about finding the measure of angle 1. We can either plug 31 degrees into x. And get 149 degrees. Or you can take 180, because we know there's supplements, and to subtract 31, and we get the same solution. So either way you go about it, we are going to get 149 degrees for the measure of angle 1. Now we are going to find the measure of two complementary angles with the same expressions. Not drawn to scale, I have measure of angle 1 is 5x minus 6, or 6 degrees less than 5 times. And the measure of angle 2 is simply x. So we're going to solve for these. It's going to be very similar. We have 5x minus 6 plus x. This time, though, complementary equals 90 degrees. So 90 degrees. Go ahead and solve. So x is going to equal 16. Once again, the measure of angle 2 is already 16 degrees. So we just go ahead and take 90 minus 16. And this equals 74 degrees. Once again, we could just plug this 16 into our expression. We will get 74 degrees here as well. This next part is all about perpendicular lines. Perpendicular lines intersect to form 4 right angles. So all of these are 90 degrees right angles. That means they are congruent. They're also adjacent because they share a vertex and a side. So this is adjacent to this one. These 2 angles are adjacent. These 2 angles are adjacent, so on and so forth. Segments and rays can be perpendicular to other line segments and rays. So if I add another one here, these guys are perpendicular to each other as well. The right angle symbol in the figure indicates that the lines are perpendicular. So even if your problem doesn't tell you that they are perpendicular, if one right angle symbol exists, that means they are perpendicular. And then this little upside down T is our perpendicular symbol. And you can write it like this as an example. So find X and Y so that lines KO and HM are perpendicular. That means these guys are 90s. They're also verticals, but that doesn't really help us here because then we'd be solving our equation with X's and Y's in them, and you can't really solve with 2 variables yet. So we're gonna just go off the fact that we know that these equal 90. So I'm going to add this guy and this guy equal to 90, and then this guy separately and equal him to 90. So I have 12x plus 6 equals 90, and then go ahead and solve. So x equals 7, and we just have to find x and y, so don't go any further. X equals 7 for that variable. We solve for y. Y is going to equal 28, I believe. We'll check it real quick. Yes, 28. Okay. This time we are going to find x so that AD and CE are perpendicular. That means they equal 90, so just go ahead and take our 2 parts. 4x plus 5x must equal 90 degrees. Combine like terms. So x equals 10. All right, so we have some assumptions here. The right side is things that we cannot assume based on our diagram, and the left side is things we can. So we can assume all points are on the same plane, that G, H, and J are collinear on the same line, that our rays in our line intersect at point H. H is between points G and J. L is in the interior of angle MHK. GHM and MHL are adjacent angles because they share that vertex inside. GHL and LHJ are a linear pair. They form that straight line. JHK and KHG are supplementary because they also are a linear pair and form a line. We cannot assume that rays HM and HL are perpendicular. We could if they had the little box there, but we cannot assume that otherwise. We cannot assume that any of our angles are congruent, even though these 2 look like it, because they don't have the markings. We cannot assume that. Same thing with our segments. Unless they have markings, we cannot assume they are congruent. So we're going to use that. Determine whether we can justify that the measure of angle VYT equals 90 degrees. I'm going to go ahead and give us that XT is a line. So we know that XT, line XT, equals 180 degrees. And we know that angle XYV equals 90 degrees. So by doing some math, we know that that leftover angle that we want to know about, that means the measure of angle VIT equals 90. Alright, this one we are going to determine whether the following statement can be justified from the figure below. Explain. So, our T, Y, W, and T, Y, U supplementary. Now we're going to go ahead and say that UW is a line. So that means angle TYU and angle TYW are a linear pair. So they are supplementary. Alright, this one, determine whether the following statement can be justified from our figure. Explain. Can we say that angle VYW and angle TYS are adjacent? The answer here is no. They share a vertex, but not a side, so they are not adjacent. This diagram you can't really say too much about, so when asked to determine whether the statement, the measure of x, a, y is equals 90, can be assumed from the figure, we have to say no, even though it looks very much like it would be. I'm going to say no. We cannot determine this. Because we don't have enough information. Okay, lastly, determine whether TAU and UAY are complementary. Now, first of all, let's review what complementary is. That means it's 90 degrees. So this means that no, they definitely are not. Although TAU and UAY may be supplementary. They're nowhere near 90 degrees. Alrighty, that's it.